Okay, so this video is going to go over adding and subtracting with significant figures. And if you did not watch the video on how to determine what are significant figures in a number or a measurement, then please check that video out. In this video, all we're focusing on is basic adding and subtracting. There will be a separate video explaining multiplication and division rules. For adding and subtracting with significant figures, all that matters is you're going to solve the problem just like you would in any normal math class or using a calculator or something like that. So I'm going to demonstrate that on the top problem. I'm going to set it up like I would back in early elementary school. I'm going to line up my decimal points just like that. The M stands for meters. And so I'm going to show it like on an addition line just like that. So I would go ahead and just add it just like I would normally. And so 9, 1, then 5. So 5.19 meters would be the answer. And that is not recording that answer in proper significant figures. So to do that, what I need to do is I need to identify where on each number is it least precise. So I'm going to find the last significant number and find out where is that being held. In this case right here, it's in the hundredths place, hundredths. In this place, it's the 10th. So therefore, we are going to round it to the least precise placeholding spot. In this case, that would be the 10th spot. So therefore, in this final number, I would round it to the 10th spot right here, which would mean that this guy follows basic rounding rules. It's followed by a 9, so it would be rounded up. This would be recorded as 5.2 meters as the correct answer. So then I'm going to do the same problem above, and I'm just going to work each one of these problems. And I've got 0.050 centimeters, and I'm adding 0.1 centimeters to that 0.1. Okay? Now, if you talked about the previous video, the zeros here don't really matter. They're just placeholders. They're not significant. And then here I've got 5. Oop, didn't mean to do that. I've got 5. That is a significant number there. And this is a significant number as well. And this one is just 1. That 0 is not significant. So therefore, if I come out here, this 0 right here is the last significant number for that number, and that's in the, not the 10th, not the 100th, but the 1000th spot, and this one is in the 10th spot. Which one of those is least precise? It's the 10th spot. So therefore, I would round this final answer, I forgot to add it down, like so. You would not record that as 0.150, that is too precise given the individual measurements. Instead, you would follow basic rounding rules where you would round this number right here, because it's in the 10th spot, because that number is in the least precise spot. Therefore, this number would be rounded to 0.2 centimeters. Now, a lot of people struggle with significant figures because they're like, wait a minute, 0.050 centimeters plus 0.1 centimeters is 0.15 centimeters. But the reality is your final answer, final measurement when recording data cannot be more precise than what your original measurements were. What I like to think of it is like this. If you are given a field like this, let me make it green. If you're given a field like that, and there's a whole bunch of blades of grass in here, okay? And you made a measurement of this small little section right here, and somebody asked you, okay, let's say you have so many blades of grass in that one small section, predict how many blades of grass there would be in the final section. So maybe you made an estimate of 10,000 blades of grass, and these had certain dimensions, and so you multiplied it out, and let's say based on the area of that, you predicted that there would be 948,200,000 or 20,000, something like that, blades of grass in that whole thing. There is absolutely no way it's that precise, because this measurement right here has so much uncertainty in it that after all the extrapolation, you can't be more precise in your final answer. So therefore, your final answer in this case can't be more precise than what it was originally. And the same thing applies here. In this case here, even though it is true that this plus this equals 0.150, it is not in terms of this number, final answer, cannot be reported in more precision than the original number. Let's do a couple more. Here's 51 milliliters, and then I'm subtracting 5 milliliters from that. Okay, this one doesn't have a decimal point, and I intentionally did that on purpose. When you subtract that, you get 46 milliliters, like so. Now let's talk about precision. The last significant number is in the 1 spot. The last significant number here is in the 1 spot. Therefore, it's going to round to the 1 spot right here. Therefore, it is okay to record this as 46 milliliters, like so. Okay. Last one. We have 55,000 milligrams, adding to it 5 milligrams. This is a great example of significant figures because this is the last significant number in that number, and that's in the 1,000 spot, and this number is in the 1 spot. So if you add these two together, you're going to get 55,005 milligrams. Well, according to this, you go by the rules of addition, you go by this spot right here, and so you're going to round that number there. Well, if you round that number, it's going to be 55,000 milligrams. So in other words, according to rules of significant figures, you add something to 55,000 milligrams, and it's equaling out to be the exact same number using significant figures. And that's all because you cannot be more precise in your final answer than what you were in the original measurements. And this number right here is not very precise. So therefore, because it's not very precise, you can't add a very precise number to it and expect that final answer to be reported with more precision. A great example of this would be, think of it like this. You got a train or a car or something like that, and then you know it's certain length. That would be similar to this 55,000 milligram. But then this 5 milligram, that's so small compared to that. Let's say, imagine you're adding a tiny little ant here to the end of it. Does it add to the length, the total length of both of those? Technically, yes. But in a measurable way, no, it does not. And so a problem like this where you end up with the same answer through addition that you did before, that's like adding the length of an ant to the length of a car or a train or something like that. This is the basic rules of adding or subtracting with significant figures. Please check out the next video for rules of multiplying and dividing.